So this video is going to be on the Matter Lesson 4 textbook pages part 1. It's going to be a quick review of solids and liquids. So on this page, really quickly, a solid has a definite shape and a definite volume. Remember that volume is the amount of space that matter fills. And it's very important that you remember that the units that volume is measured in are either centimeters cubed or cubic centimeters, cubic meters, or millimeters or liters, because those are the metric units. A solid will maintain its shape and volume in any position or container. So if you have a wooden solid block and you put it in a round bowl, it's not going to become round. The particles of a solid are packed very closely together and they are fixed, which means that since they are so close together, they have a definite shape and volume. The particles in a solid can't move around one another. They can only vibrate in place, meaning that they only move back and forth slightly. So, for example, if you have a ring of solid silver, the solid ring has a definite shape and volume. It's not going to change the shape. And the particle arrangement is similar to what you would see here, very closely packed together. There's a tiny bit of space in between them, and that's what allows them to sort of wiggle a little bit, but they're not going to move past each other. That's what makes it maintain that shape. So moving on to slide number 2, talking a little bit about liquids. Without a container, if you have a drink, it's not going to keep a definite shape. So like a solid, it does have a constant volume, and I'll explain a little bit more about that in a minute. A liquid does have a definite volume, but no shape of its own. So for example, we're going to go ahead and fill in this question right here. If you spill your glass of water, what has changed, shape or volume? Shape. So go ahead and type in shape. The volume is going to stay the same regardless of whether it's in this cup or on a table. Okay. And what you need to understand is that liquids do not expand or increase in volume when they spill. They're going to keep the same volume, but the reason they're able to sort of lay flat like this when they're spilled is because the molecules that make up the liquid rearrange into a different shape. Although the shape of the liquid changes, the volume does not. So for example, if you have a cup of water and you pour it into a 4-cup container, it does not magically increase in volume to become 4 cups. 1 cup is always 1 cup, whether you spill it on a table or you've got it in a cup. Volume is always the same. So speaking of particles of a liquid, in general, the particles in a liquid are always in contact with each other. They're pretty similar to solids, except for they aren't fixed in place, which allows them to sort of move around one another or flow, sort of like we talk about a river flows, liquids flow. And the free moving particles allow it to kind of go from place to place. And that's why a liquid is also called a fluid, because fluid means substance that flows. Because its particles are free to move, a liquid has no definite shape. However, it does have a definite volume. We talked about that. Okay. And a real life example would be swimming pools. The 2 pools in the picture here show they actually hold the same volume of water, even though they have different shapes. And so it can be a little deceiving when you first look at it. This one over here, the rectangular one, probably looks like it has a greater volume. But the fact is that liquids take the shape of their container, and these 2 have the same volume. And then this is what the particle arrangement in a liquid would look like. There's a lot more space in between the particles than you saw in the solid, which is what allows them to flow past each other. So on slide number 3, we're going to talk a tiny bit about gas. There'll be more to come on that information. When we're talking about the volume of a gas, it depends on the container. So a lot of times, you're probably familiar with helium balloons. They're filled from a helium tank. If we were to pretend like this was a small tank that can fill 50 party balloons, when you are putting the helium into the balloons, this is what the particles of gas would look like. There's a lot of space in between them. But the more helium you put into the balloon, the faster these particles are going to bounce against the side of the balloon. And that is what causes it to blow up and become larger in shape. Like a liquid, the gas is fluid, and it means that the particles can move around each other. But unlike liquids, gas does not have a definite shape or volume. The way that we measure volume for gases is what is the shape and size of the container, because they will fill whatever container you put them in. Now, we talked about the particles. They are widely spaced and they collide with one another as they fly around. And if you keep them in a closed container, they move and spread apart to fill the whole container. Once the lid is off of it, though, they will just fill whatever space they have entered. So the main thing you need to remember about the physical properties of gas is that the volume of a gas is the same as the volume of the container. So down here at the very bottom of your slide, we're going to go ahead and answer the question, what are the main differences between solids and gases? So go ahead and insert your text box. The question was the main difference between gases and liquids. So let's start with liquids. Liquids have a definite volume and gases don't. Okay? That's the first thing. And then gas particles expand to fill their containers and are more spread out and not in constant contact with each other. Okay, looking at slide number 4. This is going to be a quick review. And by the way, these look like excellent test questions. So I would highly suggest that you pay attention. So number 1, what 2 properties of a gas depend on its container? So with a gas, shape and volume are determined by what type of container. We're going to skip number 2, move on to number 3. What are the similarities and differences of the particle motion in solids and liquids? Okay, so both have particles that are always in contact, but solids have particles in fixed positions and vibrate in place. Liquid particles can slide past each other. So moving over to the other side, we're going to skip number 4 and we are going to move on to number 5. Based on what you've learned, draw models of the particles of a solid, a liquid, and a gas. Use dots for particles and arrows to show motion. So instead of doing dots and arrows, I'm basically just going to describe what you would see, because you guys are going to get plenty of practice with drawing the particles inside of each of these states of matter. So for a solid, uniformly packed particles vibrating in place. Okay. And then for a liquid, we have closely packed particles flowing amongst one another. Let me fix that for you. So closely packed particles flowing amongst one another for liquid. And then for gas, we have scattered, rapidly moving particles.